Good morning. I hope you're doing well today. We are going to continue with the 7.6 and 7.7 lesson on exponential functions, growth and decay. So if you haven't watched the first three videos for 7.6 and 7.7, part 1, part 2, part 3, you need to go back and watch this because this is the second chunk of these lessons, okay? So this is basically 7.6b and 7.7b. The other one was 7.6a, 7.7a. So I was doing the first part of both these lessons. Now I'm doing the second part, including a little bit more. Okay, so some of this right now in this video will be review, and some of it will be new. Awesome. And you will want a scientific calculator, one of those pink ones that I have in class, because we're going to use it to actually solve. So we're going to be setting them up and solving. So I should grab a calculator as well. Let me grab a calculator. We can get started. So this is the in-class worksheet. It is definitely already posted on my module. Not only have I posted this worksheet front and back, I've also posted the key to this worksheet front and back. And now I'm going to make the videos for this worksheet front and back. It does go with a homework assignment, so instead of in class, it just says homework right here. And that one is also front and back. It's 10 questions. So it looks pretty similar to this, not exact. Okay, cool beans. Let's get started. So in class, exponential functions, growth and decay. For each function below, determine if it represents exponential growth or decay. Do you remember how to do that? Exponential growth will be if the b value is greater than 1, right? The b value is greater than 1. Decay would be less than 1, but definitely greater than 0, okay? Next, we have to determine the initial amount. So what do we start with? 12 bunny rabbits? Did we start with 114 beetles? Did we start with $12,000 in our bank account? Whatever it may be. The growth or decay factor, that's the B portion. That's usually the piece that's in our parentheses. And the percent of increase or decrease, okay? So the first thing I like to do is I like to write the formula right on top. That makes it pretty easy breezy to identify our A and B piece. So our A would be 49, so maybe we're dealing with 49 ladybugs, or 49 whales, or 49 beetles, or whatever you want to make it up to be. Our B is the second number, 1.24. And because this number is greater than 1, we're talking about greater than 100% of these 49. If this was just 1, and we multiplied it, 49 times 1, well, nothing's growing and nothing's decreasing. So it needs to be a number bigger than 1 for this to increase, or a number beneath 1 for it to decrease. But 1, this keeps it the status quo, aka keeps it 49 forever. So dealing with a number that's larger is going to be a growth situation. How much growth? Well, this is 24% above 1. So it's an increase of 24%. So a quick story would be you have 49 dolphins. Their population is increasing by 24% each year. How many dolphins will there be in 5 years? And you have a little 5 right there, plug that whole thing into your calculator, and boom, you'd find the answer. Cool beans. Try the next one. So the next one's very similar. Let me scooch it over just a wee tad. So here we go. I'm going to write the formula right above it. You don't have to. It's definitely my style because I'm a visual gal. Oh, I forgot the little X on that one. So go ahead, try that one yourself. I'll give you about 10 seconds to give it a go. Give it a go. By the way, if I'm the only one doing something, I'm the only one learning. It's kind of like if I was your soccer coach and said, hey kiddo, you need to work on your corner kicks. They're not so great. The only way you can get better at corner kicks is if you get out on the pitch, and aka the field, and you start practicing corner kicks. The only way to get better at something is to practice it, right? There is no substitution for hard work. It doesn't matter where you are in life. There is no substitution for hard work. You got to get out there and try. TRY, man. Okay, so here we go. We have y equals a times bx. Remember, that is our exponential function. That's the plain version of that formula, just like y equals mx plus b is the linear one. So we have 23. We have 0.89. Because this is under 1, we know that we're dealing with a decay situation. A number of 23 dolphins is going down, okay? By how much? 11% decrease. Well, how'd you get that 11%? $1 take away 89 cents. That's 11 cents, so 11%. Now the next batch of these are just setting up word problems and plugging them in. So I'm gonna set them up, and then we're gonna use our calculator. Okay, cool. Next, look at that great question. Go ahead and give it a read. That question is a question about a car, right? So it says, you purchase a car for $54,000. Let me make sure this is straight on so we can read it the bestest. So you purchase a car for $54,000. The car depreciates 3.7% each year. Find the value of the car in 5 years. Okay, cool. Write down the formula. We have to identify 3 pieces of information. Once we find these 3 pieces of information, we just plug that sucker in, use our calculator, and we're good to go. 2 of these information pieces are kind of easy to spot. Remember, A is the initial value of whatever we're dealing with. That would be the start value of this car. X is a time. How much time? We're talking 5 years. This one's the kind of spicy one, okay? So this word kind of gives it away. Depreciate is also a word for decrease, decline, decay, okay? So that means we're gonna do 1 minus a bit, because we know it's gonna be under a 1 because it's going down. The amount that this car is worth is going down. Most cars don't appreciate. Appreciate means they go up. Depreciate, that means they go down. So cars don't really keep their value, so most of the time. Okay, so I need to turn this into a decimal. So 3.7 as a decimal, so that's 3.7. We move it over twice to the left, always twice to the left, 0.037. Use your calculator real quick if you'd like. 1 minus this, and see what you get. Go ahead and use that calculator. You do need a scientific calculator. 0.963. Now what we're going to do is put these 3 things inside this formula and see what we get. So I'm going to erase this because it's in my way. Ooh, that was smeary. Y equals 54 grand. It's a pretty expensive car, by the way. 0.963 and to the power of 5. Now if you have one of these pink calculators, I realize that doing it in front of you, even if with the calculator on, thinking you guys could see it, you couldn't. So I'm not going to even show this calculator, but I will show you one button that you will need, or a few buttons. You need the parenthesis buttons. They're down here, these parenthesis buttons. You also need this cool button right here. It's the X with a little like square. So you need the parenthesis buttons and the little square button. So use this one in class. Let's check it out. So we have this that you're going to enter into your calculator, parenthesis, 0.963, end parenthesis, hit that cool button, 5, and then hit equal sign. And what you have out is a beautiful approximation of what that car will be worth in 5 years. Remember, it started out as a value of $54,000. The moment you drive that car off the lot, it's losing money. Again, most cars are not a great investment. So your approximate value that you're going to get out of the calculator is going to be $44,722.41. You could literally just tell me 44,722. I'd be okay with that. You don't need the change on there. How'd you guys do? Good? You should try the rest of these before I do them. Okay? So come back for video number 2, and I'll do the rest of these word problems. Okay? Thanks. Bye.